In this video, we're going to try to compute the following limit of the arctangent of the cubed root of x minus 1, everything over x minus 1 when x goes to 1 from the right. Here we can do two ways to solve this question. The first one is that we can get rid of the square root here by using or letting y be this value. Okay, so here as x goes to 1 from the right, y is gonna go to 0 from the right. So that's the key that we need to keep in mind. So here we're gonna go to 0 from the right, and we're gonna have arctangent of y over x minus 1 is y cubed. And this means that we can rewrite this one as the limit as 0, as y goes to 0 from the right, of the arctangent of y over y times 1 over y squared. So here we need to know one thing here. This limit here is 1 as y goes to 0 from the right. We can prove it by changing the variable again, or we can remember the graph of the arctangent. So I'm going to do it smoothly here, and y, both functions, okay? Look here, when we are close to 0, the arctangent and y, they look the same, okay? So this is one way of convincing you that this limit is 1, and here, this limit, 1 over y squared, as y goes to 0 from the right, is plus infinity. And therefore, this limit here is plus infinity. So this is a quick way of finding the limit. Okay, here, the only thing that we prove is that this limit, I think we have seen it. We have proved it many times, different ways. Check it in the, it's on one of the videos. Okay, next we can do this limit using a different approach. So here we can see that if we let the function, let's call it f of x, the arctangent of the cubed root of x minus 1. Now, if we want to find the derivative of this function here, especially at 1, so we're going to see that f of 1 is the arctangent of 0, which is 0. Therefore, f of x minus f of 1 over x minus 1 is the arctangent of the cubed root of x minus 1 minus f of 1, which is 0, over x minus 1. So look here, if I take the limit, so I'm trying to find the derivative at 1. Okay, so if we can find the derivative of this function here, and after that checking the value or at 1 and see what's going to happen. Okay, so here note that our function is defined when x is bigger than 1. Okay, and we can find the derivative of the arctangent of ux, because this is a composed function here. So this is arctangent of u of x, with u of x is this one here. So finding the derivative, okay, so it's going to be u prime of x over 1 plus u squared of x. Okay, doing so, we're going to have, so it's going to be 1/3 x minus 1 minus 2/3 over 1 plus x minus 1 squared, 2/3. Okay, and bringing this one down, we're going to have 1 over 3, 1 over x minus 1 to 3 over 2, or 2 over 3 times 1 plus x minus 1, 2 over 3. Now we find the limit. So this is the derivative. Okay, so So we see that it's not defined when x is 1. Okay? So if we try and see here, when we go to the limit here, when x goes to 1 from the right, so here, this is going to be infinity. So it's going to be 1 over positive 0. This one is going to be 1. And therefore, it's going to be infinity. So therefore, the easiest way is to just look at this change variable. Okay? And the other thing is that this is the derivative at 1. Okay? So this is the derivative at 1 for this function. The arctangent of the cubed root of x minus 1. So here we tried and we found the derivative. But here, this is quicker. We see the limit. But remember here that we are trying to find the tangent at 1. It's infinite. So the slope is infinite at 1. That's what it means, this one here. Okay? So if we see here, or if we try to graph this function, it's going to be something like this. From the right here. So from the left, I don't know, but from here, it's going to be something like this. That's what it means.